Welcome to the boardroom. Consider this your executive strategy session for Cambridge AS and A-level computer science. Today we are breaking down the absolute strict academic benchmarks for direct addressing, specifically for syllabus 9618, though if you're building your foundations in 0417, 0478, 0983, 0984, or 2210, the analytical principles we are unpacking today are absolutely vital for your progression too. Now, picture a real Cambridge computer science past paper question, a hefty 8 or 9 marker on CPU architecture and addressing modes. The clock is ticking. I want to introduce you to two very typical students we see every single year. First, we have Alex. Alex is a walking textbook. When he sees direct addressing, he overloads his answer with every raw computer science fact he's ever memorized, but there's absolutely no analysis. He just dumps data onto the page. Then we have Sam. Sam knows the material, but he rushes. He completely misses the command word requirements. He describes when he should be evaluating. The result for both of them? A paper covered in red pen marks. If you've ever felt like Alex or Sam, if you understand the theory of addressing nodes but still miss out on top marks, you are in exactly the right place. We are bridging the gap between simply knowing the content and actually delivering exactly what the examiners are grading you on.
Okay, let's dive straight into this exclusive look behind the curtain. The quote you're seeing is pulled directly from the mindset of senior examiners. They read thousands of papers and they see the exact same patterns of lost marks over and over again. Alex and Sam are not alone. Direct addressing is often seen as a really straightforward concept, right? It's just pointing directly to a memory location to retrieve data. The operand is the address. Boom. Done. But here is the reality check. The exam questions test much more than just a basic definition. When you look at those flawed answers from Alex and Sam side by side, the red ink isn't there because they didn't know what direct addressing was. It's there because they failed to justify their points with data and strategy. Today, you are going to pitch your answer to the board. We are going to look at exactly what examiners expect from your technical answers so that you can secure those critical high-level points.
To get you there, we've structured this explainer into a highly tactical roadmap. We'll cover the core principles, the procedural framework, critical algorithm evaluation, and finally, those essential examiner insights. Let's get to work.
Starting off with Section 1, Core Principles and Assessment.
The assessment framework for Cambridge Computer Science strongly prioritizes deep reasoning over just memorizing a wide array of facts. Analytical depth is greater than superficial breadth. Remember Alex? Alex gave the examiner superficial breadth. He wrote down everything about opcodes, operands, accumulators, and the fetch-execute cycle, but didn't answer the specific question. You can't just define direct addressing and expect full marks. The examiners need to see how it interacts within the larger system. How does it affect the instruction register? What happens if the address bus isn't wide enough? This is where we reveal the strategy that top-tier students use. It's all about breaking down computer science-specific assessment objectives using the PEAL framework. That stands for point, evidence, explanation, and link. Every single paragraph you write for an extended response needs to follow this structure. You make your point, you back it up with evidence from the scenario, you explain how the hardware or software handles it, and you link it back to the specific command word in the question. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Your responses must clearly demonstrate mastery across these 3 distinct cognitive domains. First up, knowledge and understanding. This is knowing exactly what a binary representation of an address looks like. Second is application. This is where you use that knowledge in a specific, unfamiliar scenario provided in the question. And third, analysis. This is logically breaking down why direct addressing is appropriate or inappropriate for a given algorithm. Let's do a quick interactive check. I'm going to give you 30 seconds in your mind to spot which of these 2 approaches follows the PEAL framework. Approach A, direct addressing is fast because it goes to memory once, it uses the operand as the address. Approach B, direct addressing minimizes the memory fetch cycle overhead, point. In the given scenario of a real-time sensor system, evidence, this single memory access ensures the data is retrieved within the required millisecond timeframe, explanation, thereby satisfying the low latency requirement of the system, link. Obviously, approach B is the winner. It hits all 3 cognitive domains perfectly. Approach A is just our friend Alex dumping facts again.
Moving on to Section 2, the procedural framework. If you want to capture what we call the method mark, where you are awarded points for your logical process even if you make a tiny slip-up somewhere, you absolutely must follow this exact procedural sequence. This is our computer science success blueprint. Step 1. Deconstruct the question. What is the command word? Is it identify, describe, explain, or evaluate? This is where Sam messed up earlier. He rushed and described a process when the examiner wanted an evaluation. Step 2. Extract relevant data. Pull out the binary representations or memory addresses given in the prompt. Step 3. Select your analytical framework, like the Peel structure we just talked about. Step 4. Execute with exceptionally clear notation. Step 5. Present your findings with precise terminology. We are going to watch Sam rewrite his answer using this exact blueprint. Notice how the red pen marks are now transforming into green check marks. He's no longer just writing, he is engineering an answer.
Now let's look at how Alex transforms his approach. Practical application in direct addressing is ultimately about algorithmic thinking. You have to break complex problems down. You start with step-by-step decomposition. Then, you move to selecting the appropriate data structure, efficient code implementation, and rigorous testing. For the next 60 seconds, imagine rewriting Alex's purely factual answer into an applied algorithmic solution. Instead of just defining the operand, Alex now explicitly shows how a specific opcode instructs the CPU to load the contents of memory address 0101 directly into the accumulator. He's showing the sequence. He's proving to the examiner that he understands the execution flow, not just the vocabulary. Mastering this procedural cycle proves that you can think like a genuine computer scientist.
Okay, getting into Section 3, Critical Algorithm Evaluation. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get back to the strategy.
Welcome to the interactive workshop part of our session. For Challenge 1, we are doing a data scan. I want you to visualize a complex computer science data table on your screen. It shows memory access times versus different addressing modes. You have 60 seconds on the clock to extract the core trend. What are you looking for? You must evaluate algorithms by explicitly analyzing the trade-offs between execution speed, time complexity, and memory usage, space complexity. It is rarely a simple case of this mode is always better. Let's apply this to direct addressing. Direct addressing is incredibly fast, right? You have low time complexity because you are going straight to the memory location, there's no calculating offsets like in indexed addressing, and no secondary lookups like in indirect addressing. But what is the flaw you need to scan for? Space complexity. If the memory space you need to access is vast, your instruction word has to be massive to hold that full address in the operand. If you have an 8-bit operand, you can only directly address 256 memory locations. Top candidates recognize these exact trade-offs, and they justify them with the data from the table.
Let's move to Challenge 2, Find the Flaw. Listen to the sample paragraph and try to identify the sentence losing marks. Direct addressing is fast. Indirect addressing is slower because it has to look up the address twice. Direct addressing is used for simple programs. Did you spot it? The flaw is the lack of comparative connectives and specific evidence. It reads like a list of disjointed facts. When comparing multiple solutions, the most successful students seamlessly link their points. You need to identify similarities and differences using comparative connectives like whereas, conversely, or in contrast. A top-scoring answer sounds like this. Whereas direct addressing offers minimal time complexity by requiring only a single memory fetch, it is constrained by the bit width of the instruction's operand. In contrast, indirect addressing overcomes the space limitation by utilizing a full memory word to store the target address, albeit at the cost of doubling the memory fetch cycles. See the difference? That is how you use comparative connectives to support your evaluation.
Now for Section 4, Essential Examiner Insights. And this brings us to Challenge 3, Speed Writing. We are going to take everything we just learned and apply it to the examiner's core expectations.
We are now building the final answering system. Examiners have identified exactly 3 major point-losing traps that candidates repeatedly fall into year after year. These are the 3 rules that guarantee top marks if you navigate them correctly. Number 1, command word decoding. Number 2, Peel framework application. And number 3, the time management matrix. Let's break down exactly how these 3 traps manifest in the exam hall so you can avoid them entirely.
Here is the exact timeline of where things go wrong for students. Point 1. The classic trap is using the wrong algorithm or addressing mode for the context. Never apply them blindly. If the question describes a system with a continuously relocating block of memory, direct addressing is the wrong choice. You'd need indexed or relative addressing. Point 2. ignoring boundary conditions and edge cases. Students consistently forget to check what happens at the absolute limits of the memory space. If your operand allows for a 16-bit address, what happens when the program tries to access memory beyond 65,535? If you don't evaluate that edge case, your analysis is incomplete. And point 3, providing non-specific, out-of-context answers. Your evidence must be hyper-specific to the scenario given in the prompt. As we saw with Alex, a perfectly memorized definition will score 0 marks if it doesn't directly address the context of the problem on the page.
Look at this final cheat sheet recap graphic. It all comes down to this massive red flag straight from the examiners: terminology confusion. Candidates constantly try to sound smart by throwing around complex terms like immediate, indirect, and direct completely interchangeably. The fix is vital. Always clearly define your key terms before weaving them into your extended analysis. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
So the crucial takeaway here is that acing direct addressing isn't just about knowing what it is. It is about demonstrating a logical process, proving you understand the time and space trade-offs, and avoiding the specific terminology traps that examiners lay out. Armed with this strategy, I want to challenge you. How will you adapt your algorithmic thinking for the next past paper? Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Actively apply this step-by-step decomposition to your very next practice problem. Keep an eye on those command words and watch your method marks soar. Thank you for joining me for this strategy session. Let's get to work.